All right, let's look at some terms that are become very important as we move throughout physics. The first thing we're going to look at is the instruments that we use. So, tools uh, to extend the senses and refine perceptions, that is what we consider instruments. And so, we are designed to provide just essential information, and instruments are invaluable to recording and gathering information. They permit accurate and precise measurements of quantities. There are limitations because instruments are man-made, and so we are only as accurate as the instruments that somebody has made for us. And so we have to recognize that there is a difference between how accurate something is and how precise it is. And so we're going to talk about those differences in this section. The first thing we want to look at is accuracy. Accuracy is the numerical comparison of a measured value to the actual or accepted value. So, looking at accuracy, an accurate instrument produces measurements close to the accurate or accepted value. And so, if your instruments gets you close to the actual value, it is considered accurate. So, what do we mean by actual value? Well, this is a theoretical concept with a perfect instrument. If we had a perfect instrument, this is what the value would be. Now, we don't have perfect instruments, but if we did, this is what the value would be. And so, how accurate our instrument is how close it gets to that value. Accepted value, then, is an agreed upon value that is established for a particular quantity. You have a well-maintained instrument and a skilled operator, then you can get an accurate value, accurate to the accepted value, right? Obviously, you have to use instruments that are being maintained, they're not broken, and then you have to have somebody who knows how to use the instrument. So let's look at how do we calculate the error then? Percent error. The percent error, their numerator here is your observed value minus your accepted value, and then you're always going to divide it by the accepted value. So what you observed or what you measured minus the accepted value of what that thing is divided by that accepted value. And then you'll notice you have this multiplied by 100% because we are getting percentage here, the percent error here. So let's look at this. It says a student measures the density of copper to be 8.83 grams per cubic centimeters. The accepted value is 8.94 grams per cubic centimeters. What's the error of the student's measurement? And then what is the percent error? So the first thing we're going to look at is just the error. The error is going to be what we measured minus the accepted value. And so we are going to take what we measured. We measured 8.83 grams per cubic centimeters. The accepted value is 8.94 grams per cubic centimeters. And so our error is just going to be negative 0.11 grams per cubic centimeters. Well, if we wanted to find out our percent error, remember our percent error is our measured minus the accepted over the accepted, which we already have the first part of this. So the percent error is going to be the error divided by the accepted value, and then multiplied by that 100 to get your percentage. And so if you put all that in, you're going to get negative 1.2%. The negative just indicates that you were below the measured value. So the negative and positive just tell you which side of the measured value you were on. Were you below it? Were you above it? So now let's look at the word precision. Precision is the exactness of a number or measured value. Exactness. And so some physical quantities are known exactly. Measured data does not have unlimited precision. All right. If you measure something, you can only be as precise as the instrument that you are using to measure it. And so sometimes we like to confuse accuracy and precision. And so if this is the actual value, we are highly accurate. We are very close to being correct about that value, but it is low precision because we have a broad range. So you can see that our measuring tool gave us a pretty broad range, even though it's pretty accurate. I mean, it fell right here on top of the actual value. Here, we're not too far away, medium accuracy and medium precision. Well, why is this medium precision and this is low precision when this one's so much closer to the actual value? Well, you see the width here, how far away we got from our measured amount. Well, this is a more precise tool. It didn't have as big of a range. And let's look at this last one. Low accuracy, high precision. Again, what? Well, this is low accuracy because it's really far away from the actual value. But that measuring tool had really tight measurements, meaning it did not have a broad range um, when it measured. And so that's really what we're looking at between accuracy. Accuracy is how close are you getting to the actual value, and precision is how often do we get the same measurement, or how close to a measurement are we getting with the tool that we're using? So measurement should be estimated to the nearest 1/10 of the smallest decimal increment. All right. The last digit that has any significance is going to be estimated. Right. So when we get to our tools that we use, we're going to measure as close as we can, and then we are going to estimate it using rounding. So the question was, can two different measurements both be accurate? Because of limitations to measuring, it's likely that multiple measurements can be correct. If a measurement is accurate and as precise as the instrument used to measure it will allow, then the measurement is correct.